in the equation of a straight line, when the equation is written as y equals mx plus b, the slope is a number m that is multiplied on the x, and b is the y-intercept. That is the point where the line crosses the vertical y-axis. This useful form of the line equation is sensibly named slope-intercept form. Graphing from this format can be quite straightforward, particularly if the values of m and b are relatively simple numbers, such as 2 or minus 4.5, rather than something messy like 17 over 19 or 1.67385. So in this lesson, we're going to look at the real-world meanings that the slope and the y-intercept of a line can have in context. In other words, given a word problem modeling something in the real world, or an actual real-world linear model, what do the slope and intercept of the modeling equation stand for in practical terms? Back when we were first graphing straight lines, we saw that the slope of a given line measures how much the value of y changes for every so much that the value of x changes. For instance, consider this line. Y equals 3 over 5 x minus 2. The slope of the above line in the value m equals 3 over 5. This means that starting at any point on this line, we can get to another point on the line by going up 3 units and then going to the right 5 units. But, and this is the useful thing, we could also view the slope as a fraction over 1, namely m equals 3 over 5 over 1. This tells us, in practical terms, that for every 1 unit that the x variable increases, that is moves over to the right, the y variable increases, that is goes up by 3/5 of a unit. While this doesn't necessarily graph as easily 3 up and over 5 over, it can be a more useful way of viewing things when we're doing world problems or considering real world models. Okay, so we know that linear function lines can be written in slope-intercept form, which is the y equals mx plus b. Given the coordinates of 2 points, the formula for calculating slope is m equals y2 minus y1 over x2 minus x1. Also, you know that the graph of the line has its y-intercept at the point x0 equals x0 and y equals 0. Find the slope of the line through each pair of points, and then find slopes of parallel and perpendicular line to each line. So let's see, let's have an example of how, given the slope and y-intercept of the following, example of 4x minus y equals 16. Now the y, the answer will be y equals 4x minus 16, and the slope will be 4, and y-intercept will be minus 16. Another example, 2x plus 3y equals 8. Slope, this time slope will be minus 2 over 3, and the y-intercept will be 8 over 3. And the equation will be 3y equals minus 2x plus 8, or y equals 2 minus 2 over 3 x plus 8 over 3. Now,